Okay. Let's start then. So basically, we got to learn about static electricity. It's dependent on study how charges behaves. So first of all, we need to understand when there's a positive charge and a negative charge. You got yes, sorry. Oh, that's not fair. Wait a second, please. I'll do it ASAP. So basically, when you're looking at a positive charge or negative charge, you guys need to understand that positive charge is a charge where the field goes out of it from a single point. Seems like it's going out from a single point like this, okay? Please let me do it. Okay, this line doesn't agree that we should go from here. No way. Be precise, please. Okay. Doesn't want to be precise. Okay, anyway. So from a positive charge, it feels like the field is like going out like this, okay? The field lines go like this. From negative charge, the field seems like it's going in towards a single point like this. This would be negative, this would be positive, alright? So do remember that field out from positive, in from negative. Now, when there is a positive charge and there is a negative charge, they basically attract each other. And when there is a positive charge or positive charge, basically they repel each other. Same goes for a negative charge and negative charge, they would also repel. What basically this tells us is that like charges attract, unlike charges attract, and like charges repel, just like this. Now, speaking of this then, we also need to realize that basically when charges are there, they create an electric field. Now what exactly is an electric field? Electric field is basically a region where an electric charge feels a force. Alright, the force can be attraction or repulsion depending on what type of field that is. Anyway, so first of all, we're going to learn what is a non-uniform electric field. Non-uniform electric field means you can draw the diagram like this. So the lines will go out from positive into the negative like this, and they're all sort of disorganized, unorganized like that, like this. Always out from positive, in from negative, and same goes for the other side, but in from there like this. So like that. Okay. Now if charges are like charges are placed together, then what happens is their fields do not connect. They repel each other. So because they don't like each other at all. And because both are positive, so lines will be out. For a negative, it would be the same type, like the same type of field, but it's more like the arrows directions are just bit more opposite. Okay, they're towards the charge like this. So same type of field, just the arrows direction is like different, and you guys should remember this. Okay, you guys can draw this, and then I'm gonna move forward. Take your time, please. I'll be back. I just need to get me water. Okay. Everybody done? Any questions, please? Let me know.
So we have to know that the period between the two things is on the neutral group.
The middle of two like charges is what?
It's called the neutral group.
Not necessarily, but it's not exactly the neutral point. It's basically this point is called null point, just for your information. It just means that here charge would not experience force because field doesn't exist here. Do you understand?
Yes.
Yeah. But I haven't seen at your level. I don't think so. It's that important. Anyway. So then we have uniform electric field. Now uniform electric field has certain qualities about it. Number one, lines must be straight. Lines must be parallel, and lines must be equally spaced. So this is like the qualities of a field, a uniform field. Okay. So in any case, if he asks this, okay, from you, and he's like, okay, please tell us if it's like, that. So you guys should understand that you should be drawing at least 4 lines. Okay, at least 4 lines must be drawn. This doesn't look very nice. I'm just gonna draw more in your exam as well, and they should be like equally spaced like I'm making them, and like you don't necessarily need to use a tool, but it should look, at least from the eye perspective, that they are straight in the center. They're like this. At the end they curve a bit, but that's not important right now. Now, why is this uniform field? Why do we call it uniform? The reason we call this uniform is because at all points within this field, electric field strength, okay, the amount of force, which is basically electric field strength, means force per unit charge, okay, this is what it means, is same. Like, that's why it's uniform, it's same. That's why you call it uniform, and it can only be created, like I'm just writing a note here. can only be formed between two parallel charged plates. Like there's no other way to form them, just parallel charged plates. Alright, is it clear everyone? Any questions? Yes, Iman. You want to say something? Okay. Now then, why is this? The question is, why is this that the field is going from positive to negative? It could be negative or negative to positive also. But the reason why field is this, because the direction of field depicts the direction of force on a stationary charge. Stationary positive charge. Positive charge means if you place a stationary positive charge, wherever it will go due to the force, that would be the direction of field. Like for example, if I could draw a charge here, let's suppose a charge positive, so obviously it will feel a force this way, which is the same direction as field. That's why we take positive to negative. So that's a convention like this. Alright, is it clear everyone? You can write this please. What I mean by this is the direction goes from positive to negative, right?
Yes.
So why can't it go negative to positive? Why is it that it has to be positive negative? Because it is depicted by the direction of force on a stationary positive charge. Like you see, if you place a positive charge anywhere, it is going to feel a force in the same direction as the field direction, okay? So that's why it's like a convention that we do. You get it? Okay.
Yes.
Pretty good. So then, strange. Okay, I got it. So then we're going to go to next one, and now this is basically it says describe what is meant by electric field. Who can tell me what is electric field? Anyone? Region where a charge feels a force. Very good. Then it says two parallel conducting plates are connected to battery, and they say draw field lines to show electric field. Now I'm going to give you this homework because I've just already done this, but what I want to basically tell you is right now, how would we know which is positive plate and which is negative? So when you look at a battery, the longer sign is the positive sign and the shorter sign is the negative sign, which makes this plate to be positive and this plate to be negative. Is it clear everyone?
Yes.
Now you know the drill, and you're gonna draw this on your own and submit the work so that I can see them. Okay. Now I'm gonna do this question. Already you will do this as this, because it says describe what is meant by electric field. You already know that region where a charge feels the force. State what is meant by direction of an electric field stem. Can somebody please tell me that?
Direction in which a charge experiences a force.
No. Why is it that it has to be always positive to negative? That's what they're asking. You get it? Now, go back into the notes, read what is written here. It says,
Okay.
yeah, So the direction of field depicts the direction of force on a stationary positive charge. Is it clear, everyone? Will you be able to write it now?
Sure.
That's all they're gonna ask. Now, in this question, it says there is a positively charged plate, and there is a negatively charged plate, and polystyrene ball covered with aluminum paint is given, right? It says the ball oscillates between two charges plates. Why the ball oscillates? Okay, so this is the question. Now, if you look at this question, you realize that basically there will be an electric field. Do you guys agree with that?
Yes.
Okay, if there is going to be electric field, that would mean, like, you're going to say there will be an electric field generated. So 4 points for 4 marks, okay, between the two plates. Okay, please write this down. Because this is a difficult question, I just wanted to make sure that you guys are well aware of this. Okay. So, now what is happening? The polystyrene rod ball covered with aluminum gets charge induced on it. Okay, I'll just explain this to you what induction means, okay? So, when it is attracted by negative plate and touches it, it gets negative. Okay, so if the ball touches here it gets negative and repelled. Okay, then it touches, like when it moves back, it hits this side, so then it touches positive plate, becomes positive and get repelled, because positive and negative repel each other, okay, like this, that we already know. So that's why it keeps on oscillating. Is it clear, everyone? Any questions?
No questions, sir.
Okay, now this part you don't have to do right now, so I'm cancelling this out. It is from the next chapter. It's a mixed question, that's fine. Anyway, the rest of it you have to write. Then we're going to learn about electrical conductors and insulators, okay, and what is the difference between them and why do we call them like that. So when we say something is an electrical conductor, it means these are materials, those have free electrons. Like some teachers teach it as sea of electrons. Both like terms are correct. That helps charge to move quickly across them. For example, all metals are just good electrical conductors, okay? Now, for electrical insulators, the thing is that these are materials which do not have free electrons. So they resist the flow of charge, okay? and they are like mostly non-metals like glass, perspex, wood, etc., rubber, etc. Okay, you can write rubber as well. Okay, then the thing is that we can still charge the insulators, and there's a way. The charging of insulators is done by friction. So we're going to write about that in a bit, but okay, let's write it down. It doesn't matter. Okay. Charged by friction, and friction means that you need to rub them with another insulator. So I'm just gonna tell you how it makes it possible. So basically, when you rub something off, when something is neutral, basically neutral means that it has like the same number of positive charges as the negative charges. So if they're equal, then obviously what we draw is we draw it like this. We don't show any charges. That means it's neutral. Is it clear, everyone?
Yes, sir, but what have you written about?
Charged by friction, rub
No,
them with
sir.
another insulator. Actual?
Sir, okay.
Actual. This is the actual depiction. Okay. Oh, that's an actual thing that we see. Like we don't see, that's actually there. And how we depict is like the ones I'm going to draw down. Okay, is it clear?
Okay.
So if something is positively charged, that means it has more number of positive charges than negative. So overall, how we draw it, how we just depict it like this, we just draw positive charges on it and we say, okay, it's positively charged. It doesn't really mean that all negatives are gone. It means it is now more positive than negative. Is it clear?
Yes, sir.
Now, for something like a negatively charged object, what you need to understand is they're like, which means they have positives, but they also have more negatives. So if they have more negatives, then obviously we just draw negative charges and we say it's negatively charged. That doesn't mean it does not have positive charges. That means it has more negative charges. I hope you guys understand this, okay? Now the most important thing, and that is the golden rule that I'm going to write in blue, is that only negative charges can move to or from a material. Like positive charges, you guys might have taken chemistry and you might have learned that positive charges live within nucleus, so positives do not move. It's only you can gain electrons or you can lose electrons. Do you guys understand this?
Yes, sir.
Good. Now, for example, if you see a positive charged object, so the right description, if something becomes positive charge, the right description would be that it is positive because it has lost negative charges. Alright? Notice that I do not write that gains. So, what is the wrong depiction? We're going to write in purple. So, do not write it gains positive charge. If you write this, it would be wrong. Is it clear, everyone? Good.
Yes, sir.
Now, If something is like negatively charged, so what would you write about it? You'd write it is negative because it has gained negative charge. And what you don't have to write, so do not say that it loses positive charge. That would be wrong and unacceptable. You get it?
Yes, sir.
Interesting. It's very, very nice. Okay. So then we're gonna go forward, see what's next. Yeah. So it says a plastic rod is rubbed with a dry cloth. The rod becomes positively charged. Why has the rod become positively charged? Can somebody please tell me the answer?
C.
Yes. Why can't it be? Yeah, it's C. Because it will lose electrons. It cannot gain protons, alright? Something like that. Please don't write that. Okay, good. Very good. Now, in this question, it says two isolated metal spheres are both negatively charged. The spheres are brought close to each other, but they do not touch. Which diagram shows the charge distribution? Both are negative, but negatives and negative repel each other. So, what do you think would be the answer?
Okay.
Sorry? What do you think?
Is it D?
It will be D because both will move away from each other. Very good. Then it says a plastic rod is brought near to plastic sphere suspended from a stand. The sphere is repelled by the rod. Why is this?
B.
B. The charge and have unlike charges.
No, A.
Yes, very good. It has to be A because only like charges repel. Okay. Is it clear? Yusra and Smiley and Caroline, Chavez,
Yes, sir.
Iman. Okay. Now, so then we got to learn how to charge the metal conductors. Okay. So when you have to charge, basically you guys need to understand few things about it, and then obviously you will learn. So the first step is
Sir,
yes.
so I don't understand why question 27 is not D. Why is it D?
Because these charges, how are they coming closer? They should be going away.
Because the positive charges are on the left side of the second sphere.
No, initially they would be like this. Initially they would be like this, Imad. So when you brought them closer, then these guys have to go on the other side. These guys have to go on the other side. Do you understand? They haven't shown you the inertial thing.
I'm still not convinced.
Okay. Charges, when they're alone, right, they're equally distributed. Like if something is negative, they're equally distributed along in the whole sphere. Okay. If you bring another charge sphere with also negative, so these negatives and those negatives repel each other. So they will go as far as possible from each other. Do you understand?
Okay.
So these will go here and these will go here. Like why it can't be B? Because if what this shows is that initially they were like this, and now all of them are going this way, like they're going, oh my god, this way, which is not possible, because how is it that they're getting attracted to this side? They should be going this way. Do you understand? Like that, Imal. Do you get it?
Okay, sir.
Okay. With your logic, then it would have been C would have been correct as well, no? Because if they can go this way, why can't they go this way? You get it?
But because I think they are Earths.
They're not Earth. They did not say they're Earth. Does the question say that?
Because like charges repel.
Yes. So they will go like, if you have somebody you hate, okay, and that person also hates you, so you would run away from that person and the other person would follow you. Is that possible, Imal? So that person will also run away from you. So they will try to become as far away from each other as possible. Do you get it? Like that.
Okay, sir.
Always remember that. Now, so when you have to charge a metal conductor, what you're going to do is you're going to bring a charged rod close to it. So let's suppose the charged rod was positive, and this is like a plastic rod or whatever. Okay, it doesn't matter. Now, conductors cannot be charged by rubbing. If you rub them, because they have so many electrons in them, it doesn't really matter. Friction doesn't remove electrons, so it's just useless. So if you bring positive, because this is a neutral right now, so what will happen? Negative charges, because the rod was positive, the negative charges are going to get attracted towards the positive, leaving positives on the other side. Do you guys understand this? So the description would be, negative charges get attracted to positive rod. Okay, now then what happens is, so you go here and then it comes back here. So for a metal sphere, now you have the rod at the same place. I forgot to make a rod. And then what you do is you connect earth wire, like, you connect earth wire on this side. So this is the symbol of earth. Now earth contains all sort of charges. Okay, so earth can donate electrons or take them away, depending on the situation. So right now the situation is that you have negative charges here and positive charges. So earth would think that this metal sphere is basically positive. So what will earth do? Earth will send electrons towards the metal sphere so that it can neutralize it. Do you understand this? So the description would say, earth will try to neutralize the side by sending electrons. Now, then what you do is you basically first, so we are trying to trick earth, so we remove basically earth wire. When we remove earth wire, what happens is, now we have more electrons in it. We took some extra electrons from Earth. We have more electrons and less protons now because we took electrons from Earth by deceiving Earth. How clever we are. And then we would remove the rod. When we remove the rod, then this metal sphere will be dominantly negative, and now we have charged it as a negative sphere. Do you guys understand this? Okay. All right. Everybody gets it? Yusra, Smiley, Iman, Zainab, Imal, Shawez.
Yes, sir. Yes, sir.
Sir, what is induced?
Induce means temporarily, like charges are like split. Okay. Okay. So I'm going to show you how it, like for example, this is called, like in this section it is like induced charged. Induced charged means that this rod is making electrons and protons getting separated. That's how the charge is induced in it. Is it clear? Just like that. Anyway, so for example, this question, and questions will be like this. It says a metal sphere is charged by induction. Okay. There are 4 stages: W, X, Y, and Z in this process. W, a charged rod is brought close to sphere. The sphere is Earth. The charged rod is taken away from sphere, and the connection is removed. Which order are the 4 stages carried out? Can you please tell me that?
B.
So first we need to bring a charged rod, then we can earth it, then we have to remove Earth's connection and then take the rod. Is that correct? Yes, you guys?
No, sir.
Okay. So that is correct. Why? So question is, what will happen if we remove rod before Earth? Can somebody please tell me?
Sir, what will be A then?
This is what I'm saying. Why can't it be A? If we remove Earth before, like rod before Earth, what will happen?
Will it become neutral again?
Yes, so Earth will understand that we have tricked Earth and we are very bad people. So Earth will take the extra electrons back. Do you guys understand this?
Yes.
Good, very nice. So then that would mean that we're going to go forward. Now, in this question, I'm going to give this to you as homework, but if you don't understand this, do let me know, okay? This is the same thing. Just, where the positive and negatives will be and blah, blah, blah. And you will have to, okay, I'll do this. This is kind of one concept that is new. So it says a negatively charged rod is brought near to X and Y, which are touching. So what are the signs and relative magnitudes? So what will happen? What do you guys say? What will be the charge on X? It will be positive. What will be the charge on Y? It will be negative. Why? Because Imal, negative charges will try to run away as far as possible from the rod. Do you understand?
Yes.
Now, will they have the same magnitude of charges on both of them or different? Who can tell me this? it will be equal, because if equal number of charges are coming here, equal number of charges will be here. So you guys need to understand the separation is equal. So charge on X would be positive and Y negative, and they should be equal. Everybody understand this? Yes, Emma?
Sir,
Yes?
the spheres are like touching, so does it mean that the electrons will go to the other sphere?
Yes, electrons would go to the other sphere, and same number of electrons would go uh, with respect to the same number of protons that are left behind. Okay? Good. Now, so going to the next one, this is, you guys will be able to do it. This is easier than the previous one. And obviously, try this one on your own as well. This is very easy as well. So now we just need to learn how it is possible for the Earth to discharge. For example, if we remove the rod first and it's kept like this, if the sphere was initially, suppose we try to make it positive, okay, we should make it like, if initially it was like positive and we connect earth wire, okay, with it, so earth wire will know that this was positive. The earth wire will provide electrons, okay, to make it neutral. All right, earth provides electrons. If we try to put earth wire on something that it was initially negative, then earth would take these negative charges back. So earth takes extra negative charges back to neutralize. All right, so do remember that. All right, is it clear, everyone? Any questions now? Let me know.
No.
Okay, so then we're gonna go to this one. It says on figure draw arrows to indicate the pattern, because this is like, uniform, so we just need to make nice arrows like this, okay, straight lines all over it, and just make it, oh, this is negative, my bad, the arrows will be towards the charge, okay, like this. Then says a smaller charge is there, draw indicate the distribution on S. So this is negative, so positive charges will come, so this side, negative will go to the other far end. Then says what happens to S. Obviously the negatives and the positives will attract, so sphere S will be attracted or moved towards the charged sphere. Okay, the earth wire is then touched against S. Describe what happens to wire and state how this affects the charge on X. S. If you touch an earth wire, okay, if you touch an earth wire, then what happens is the electrons will be taken away. This will become positively charged, okay. So extra electrons are taken away, and the sphere S becomes positively charged. So you just need to write that, the one that we've just done. So it's pretty easy in that sense that it just keeps on asking the same questions all over again. Okay. Then says a metal sphere is an electrical conductor. The plastic thread is an insulator. Explain this difference by referring to structures of the two materials. Who can tell me this? Why we call something as conductor and why we call something as insulator, please?
Conductor has three electrons, while insulator doesn't.
Yes, very good. You can write it down. Homework, and obviously, this is also homework. Do it today, please. And now we're gonna go to the gold leaf experiment. So in gold leaf experiment, there's a brass disc and rod, and then we have a gold leaf. And what happens is that when you bring a charged rod close to it, so it can identify charge. For example, we can detect charge through it. For example, there's an unknown charged object, okay? Charged object, unknown object. Okay, we don't know whether it's charged or not charged. So what happens is when you bring it close, suppose this was like positively charged. Okay, we didn't know that. So what happens is that the electrons from the end will travel upwards and gather on this side. When the electrons gather on this side, relatively this side, the other end becomes positive. Do you guys understand this? Now what will happen that this gold leaf is gonna get repelled. Gets repelled because there is like positive gathered on both sides. Do you guys understand that?
Yes.
So gold leaf gets repelled if rod is charged, and if rod is not charged, like if rod was not charged, so gold leaf will not move if the rod was uncharged. So this is like pretty easy to check if something is charged or not. As simple as that. Okay. Okay. Then we can also identify the nature of charge on anything. For example, suppose that we have a gold leaf which is already positively charged. Okay, so that we know that if we bring a rod close to it, what will happen? So if we bring a positive rod close to it, what will happen is that because positives repel positives, so here more positives, like sort of, it will enable it to have like repulsion effect, which means electrons will further move up. That means that this gold leaf will be repelled even more. So if the same charged rod is brought closer, the leaf will be repelled even more. And the reason is because both charges, like charge on rod and charge on the brass disc, are repelling each other. Is it clear, everyone? Any questions?
No.
Now, if you bring a negative charge, however, towards a positive, like gold leaf electroscope, then what happens is that because the electrons get repelled, or we can say positive attract, so the leaf is gonna fall. It's gonna fall. So we're gonna say that if the opposite charged rod is brought closer, the leaf will fall, because now it will have less repulsion. Okay, is it clear everyone? Any questions? Let me know.
No.
That's pretty awesome. So then we're gonna move to the last part, which is here. So it says the diagram shows two thin uncharged strips of plastic. Diagram 2 shows the same strips after they have been rubbed with a dry cloth. Which row describes the charge on strips after rubbing and the force between the strips after rubbing?
B.
B. The charges are opposite and opposite repel. That's what you're saying? D is correct because they must have the same charge and the same charge causes repulsion. That is absolutely correct. Do you guys understand this? Any questions now? I don't think so there is anything else. So yay, we have finished this topic and I believe you guys will